Mixture of architecture is a new architecture for personalization of generative models that disentangles the generation of given subjects and the context from the prior. I think it will be best explained by showing you first its little demo from their project page. So let me show you that. If you look at this diagram and then let me slide this slider to the right a bit and just keep looking at this image. And you can see that how quickly and seamlessly it is changing. There you go. So we are just traversing the initial random noise, which changes the context consistently across different subject pairs. So there you go. You see, not only the clothing is changing, but also the faces are being changed. So this is what this mixture of attention can do. There you go. How good is that? And it is changing in real time from the GitHub. Amazing stuff. So this is what mixture of attention can do. Now on the left hand side, you see that there is a standard attention, and on the right hand side, we have the mixture of attention. Let me try to explain it as what is happening here first. So you see, recent progress in AI generated visual content has been nothing short of revolutionary, fundamentally altering the landscape of digital media creation. Foundation models have democratized the creation of high quality visual content, allowing even novice users to generate impressive images from simple text prompts. Among the numerous avenues of research within this field, personalization stands out as a crucial frontier. It aims at tailoring the output of a model to include user specific subjects with high fidelity and producing outputs that resonate more closely with individual assets or preferences. While being able to say, create a photo of people scuba diving is fun, the experience becomes personal and fosters a stronger emotional connection when one can say, create a photo of me and my friend scuba diving, or create a photo of me and my partner swimming, something like that. Despite the remarkable capabilities of these models, current personalization techniques often falter in preserving the richness of the original model. That is, we refer to the model before personalization as a prior model. In fine tuning based personalization techniques, due to the modification of the weights, the model tends to overfit to certain attributes in the distribution of the input images, for example, posture and composition of subjects, or struggles to adhere adequately to the input prompt. This issue is exacerbated when it comes to multiple subjects. The personalized model struggles to generate compositions and interactions between the subjects that otherwise appear within the distribution of the non personalized model. Even approaches that were optimized for multi subject generation modify the original model's weights, resulting in composition that lack diversity and naturalness. That is why it is really recommended to pursue a personalization method that is prior preserving, and also um, and that method in this paper is called as prior preserving if the model retain its responsiveness to change in its text prompt and random seed like it does the prior model. So if you look at this diagram, unlike the standard attention mechanism, which is on the left, mixture of attention or MOA is a dual attention pathways that contains a trainable personalized attention branch and a non-personalized fixed attention branch that is copied from the original model or prior attention. In addition, a routing mechanism manages the distribution of pixels in each layer across these branches to optimize a blend of personalized and generic content creation. How good is that? Okay. Now, if you look at this diagram, this is another way of looking at it. For example, when we visualize the router predictions of MOA, we can see that the router put the background pixels to the prior branch and most of the foreground pixels to the personalization branch. This behavior explains why MOA can achieve disentangled subject context control. The detailed behavior of the router differs across layers and time steps. This allows the personalization branch to focus on different regions within the subject, the face, the body, and on at different timestamps. Now let me show you a few more examples. For example, look at this. In this, they have simply, let me make it slightly smaller. There you go. They have simply changed the person. And this is personalization at its peak. This is simply scary or amazing, depends how you take it. So that is where these researchers have introduced mixture of attention, and that is inspired by mixture of expert layer and its recent success in scaling language models. MOA extends the vanilla attention mechanism into multiple attention blocks, that is experts, and has a router network that softly combines the different experts. In their case, MOA distributes a generation between personalized and non-personalized attention pathways. It is designed to retain the original model's prior by fixing its attention layers in the prior branch while minimally intervening in the generation process with the personalized branch. The latter learns to embed subjects that are depicted in input image via encoded visual tokens that is injected to the layout and context generated by the prior branch. This mechanism is enabled thanks to the router that blends the output of the personalized branch only at the subject pixels by learning soft segmentation maps that dictate the distribution of the workload between the two branches. And this mechanism truly frees us from the trade off between identity preservation and prompt consistency. Now, in this image, you can see that we have simply swapped the face and body, and then you can also simply swap whatever you like. So this is on the left is the original image, and then you look at the swapping in different attire, and you can even just simply swap the whole body and then run with it. So mixture of attention is able to swap subject despite very different body shapes. So you can see that the body shapes in these two different rows totally completely different, and yet mixture of attention was able to do it flawlessly. And this can also morph it, as you can see here. How amazing that is. I mean, simply things are getting crazier, I mean, by the day, and it is not stopping. So, but having said that, I believe that we should keep in mind all the ethical and responsible issues here, because this could get out of hand very quickly. I mean, you can already sense that how negatively and how harmfully this sort of research can be used, and it is just a matter of issuing text prompt to do these changes. So hopefully there will be some regulations, some controls there in order to tackle these sort of things. Also, the weights of the models are still not there. I checked out its GitHub repo, but the link is not working. But anyway, I will put the link to this project page in video's description. Let me know what do you think. And if you like it, then please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.